Hello student, in this class we will learn about the states of matter here. See, thing is that in previous classes what we have seen in the previous as well as in the lower classes, we have three states of matter: solid, liquid and gaseous. So now we will talk about one by one here. So very first thing we will talk about the solids here. So if I am talking about the solid here, what is the first and important property with the solids? They have a fixed shape and the fixed volume also. So this is quite common. Let's say for example, if I am talking about this pen. So this pen is solid in shape. So it has fixed shape, see, and it has a fixed volume also. So generally solids are carrying these kind of property. So property like they will have the fixed shape and they have the fixed volume. Solids cannot be compressed much because the intermolecular space is very less between them. Intermolecular space is very less, so that is the reason the compressibility of solid is very less. Now if I am talking about the third point here, solids have high densities and they are heavy. High densities means per area. If I am talking about the specific area, if I am having any area, in that area the number of particle size is extremely high in the solid because of this reason they have high densities. And if they are having high densities, they are heavy also in nature. Solids do not fill their container completely. Sometimes this is possible, sometimes this is not possible. Fine. So generally if I am going to keep any solid in any container, so this is not going to fill completely, maybe partially or maybe I think low percentage. Another critical important aspect of the solid is that they do not flow like liquids and gases. So here we have some example of the solid here. So this is my brick here, and what you can see here inside this brick you will find this kind of arrangement. Intermolecular space are extremely slow in that. So the compressibility is not possible here. If I am talking about the more examples of solid is ice, wood, coal, stone, iron and brick here. Now if I am talking about the liquids here, liquids have a fixed volume but they have no fixed shape. So please do remember, this is very important. If I am talking about liquids, they have a fixed volume but they have no fixed shape. Liquids can take the shape of the vessel in which they are placed. For example, if I am going to fill 1 liter of water in a bottle, so it is going to take the shape of bottle. The same 1 liter water if I am going to fill in a container, so that is going to take the shape of that container only. So that is the reason I can say liquid have no fixed shape but the volume will be same. Volume will be same means, see, 1 liter water will be the 1 liter only. Whatever the vessel I am going to use, the 1 liter will be the 1 liter only. Now, like solids, liquids cannot be compressed much because of the same reason, my dear student. If I am having less intermolecular space, the compressibility is not possible with any matter. Generally, in case of solids and liquid, in liquids, yeah, compressibility somehow is there. But in solid it is extremely low because they do not have any intermolecular space between them. Now liquids have moderate to high densities. They are usually less dense than the solids. Very nice I think point here, because whenever I am going to compare with the solids and liquid, and if I am trying to compare the densities, the liquids have less densities than the solids. Liquids do not fill their container completely. Sometimes it is possible and sometimes this is not possible. Liquids generally flow easily because the space between the intermolecular space is between the solid and gases. That is the reason they can flow easily. Now what about the property of liquids here? See, here I have the one liquid which is filled in the bottle. So what you can see here, few examples are here: water, milk, fruit juice, ink, groundnut oil and kerosene. These are the few examples where I can see the liquids here. Fine. Then after that, if I am talking about the gases, has neither fixed shape or nor a fixed volume. So remember, my dear student, please try to understand about the gases. They do not have a fixed shape. They do not have a fixed shape and fixed volume. Gases acquire the shape and volume of the vessel in which they are kept. For example, if I am going to fill a gas in a balloon, so it is going to take the shape of balloon. Even the no fixed shape and no volume, fixed volume with the gas. Gases can be compressed very easily. This is another important point, or you can say the property with the gases, because the intermolecular space between the gases are extremely high. If intermolecular spaces are extremely high, so we can compress them so nicely. So it's all about the intermolecular space. Now gases have very low densities, because if I am talking about the unit area, so in that unit area the number of molecules is very less. That's the reason they have low densities. That's the reason they are very light also. Gases fill their containers completely. Okay, this is another important aspect of the gases here. For example, if I am going to fill gas in any container, it is going to occupy the entire space there. Gases flow easily because there is a lot of intermolecular space between them, and even the kinetic energy of gaseous molecules are very high here. So student, what we have seen? We have seen about the solids, we have seen about the liquids, and we have seen the gases and its basic properties here. So student, what is next here? Here we can give some example here. For example, air is another example of gas. Air is what? Is a mixture of gases. And if I am talking about the particular gas here, so we have the oxygen, hydrogen and nitrogen. We have specific gases which are available in air here. So here is the example, the balloon which is filled with the gas. As you can see here, the intermolecular space between the gas molecules are, you can say, the highest. See, this is the intermolecular space. The space or the distance between the two molecules of gases is extremely high, as you can see in this diagram here. So that's the reason its compressibility is extremely higher. So here we have the comparative analysis of my solids, liquid and gases. If I am talking about the mass in all solid, liquid and gases, it is definite. If I am talking about the shape in solid, it is definite. And what about the liquids? Acquire the shape of container and acquire the shape of container, same gas and liquid. If I am talking about the volume, volume is definite, and liquid, they are also definite, but in case of gases, this is indefinite. Now compressibility, no possible, because as I told you already, intermolecular space is very less, almost negligible but more than the solids, and highly compressible. Fluidity, not possible with the solids, as we know that they cannot flow. Liquids can flow, even gases can flow. Rigidity, highly rigid in shape and size, less rigid, and they are not at all rigid in case of this. Diffusion is very slow in case of solid, it is very fast in liquid and extremely fast in case of gases. Space between the particles, if I am talking about most closely packed structure, as you can see here, loosely closed because you will find some space between the molecules here, and the least closely packed you will find most of the intermolecular space in the gases only. Now interparticle force is the strongest, that is the reason they are very close to each other. If I am talking about the liquids here, slightly weaker than in the solids, if I am going to compare with the solids here. And here the negligible means nothing, none. Interparticle force of attraction is none in case of my gases here, because the intermolecular space is extremely high here. So they will not feel any kind of interparticle force of attraction or anything. So student, what we have seen here, we have seen the comparative analysis of solid, liquid and gases on these points, on total 9 points here. So this summary is extremely important just to compare all the 3 states of matter here. So student, this is all about here. Thank you so much.